Hi Faiz! So it's the month of June, and aside from high school exams, there's also high school graduation. Don't you remember the good old days? Now wouldn't it be nice if we could travel back in time and return to the good old days? Well, you can't. See, traveling back in time is pretty controversial, and a lot of scientists think that it's impossible. Now, speaking of time travel, do you know that we can travel forwards in time, but at different speeds? That is, to make time go slower. Welcome to the theory of relativity. So before I begin, I would like to introduce you to Snowball. So Snowball decides to take a walk. And to me sitting here, Snowball is walking to the left. But then what does Snowball see? To Snowball, she's not moving away from herself, so I'm actually moving to the right. Well, as Snowball's walking, she decides to throw a ball. Well, that ball, to her, is moving at the speed at which she threw it, which is, let's say, 10 meters per second. I'm sitting here, what do I see? Well, the ball is moving at 10 meters per second plus the speed that Snowball is actually moving. So measuring the speed is actually different depending on who's measuring it. And this is what we call reference frames. Basically, a moving object's speed and direction is relative to the observer. Alright, so that's very normal. But what if Snowball decides to shine a light as she's walking? You see, light travels the same speed for everyone, no matter if you're moving or standing still, and that is 3 times 10 to the power of 8 meters per second. And now that's where things gets weird. Light travels at the exact same speed no matter which observer you are. So if two people traveling at different velocities, and they want to measure how long it takes for light to travel from one place to the other, they will actually disagree on the time that light took. Imagine Snowball's walking, and he shines light directly downwards onto the ice. It will strike the ice and it will reflect back to her. But if I'm standing still and I'm watching her from the side, I'll see the light making a triangular shape because she's moving. Essentially to me, the light had a longer distance to travel than Snowball. However, light moves at the exact same speed for me and Snowball regardless who is moving. Because I see that the light had to travel a longer path, to me, that light took longer to reach Snowball than to Snowball herself. Therefore, in the exact same event, I have noticed something completely different than what Snowball saw. And this is because the concept of time is not the same for me or for Snowball. 1 second is different for different people. Time is relative. This phenomenon is called time dilation, and it's one of the major discoveries of relativity. Basically, the faster you go, the slower your time will run with respect to someone who's standing still. So let me give you an example, the twin paradox. Okay, so imagine that you and I are born at the exact same time. And at that exact moment, I go on a spaceship that travels at near light speeds off into the universe while you stay here on Earth. So let's say 30 years have passed on Earth and I return. Well, you're gonna be 30 years old, but if I'm traveling fast enough, I'm only gonna be 10 years old. And this is because of special relativity. Because I'm traveling close to light speed, time for me went at a different pace than time for you. And to me, it went slower because I'm traveling faster. With respect to you, that is. So believe it or not, relativity actually affects our lives a lot. It's what makes the GPS work. So currently, there are many GPS satellites orbiting the Earth. So many that no matter where you are standing, there will be at least 4 satellites right above you. So what these 4 satellites do is they constantly send signals to your GPS telling it where they are and what time it is. Your GPS then does some math and calculates where you are on the planet and how high you are above ground. But the satellites are orbiting so fast that their clocks are actually running at different speeds. So imagine if you did ignore relativity. Well, in that case, if you put a GPS on a tree, you'll see that the tree zooms across the Earth because everything is out of sync. So to compensate, satellites are constantly synchronizing their own clocks with respect to each other so they can give you the most accurate results. And there you have it, learning to manipulate time with relativity. So although we can't go back in time to make us younger, we could go forward in time slower to make us age less. And how do you do that? You start running as fast as you can. Okay, probably not. After all, you can never run close to light speed. But if you really want to age less, be an astronaut and just go into space, travel as fast as you can. Anyways guys, I'll see you on Monday.